Thank you. Thank you very much, Ellen. Thank you. I am delighted to be here. It's a great honor for me, and Ellen will tell you, everyone here will tell you that I jumped at the opportunity to be able to be in front of all of you tonight. Doctors Richard Leakey and Donald Johanson are the two best-known anthropologists alive today. Just think about that. Between them, they have spent nearly 100 years searching for human fossils in Eastern Africa. Some of the most important fossil finds of our time, really, that have placed a real bearing on human evolution and answered a lot of questions, including 3.2 million-year-old Lucy and 1.5 million-year-old Turkana Boy, were recovered by their teams. Just a little bit of background. Tonight is a real treat, ladies and gentlemen. That's how I feel about it, as a discussion about from where we came, how exactly it may have all happened, and who we are as human beings. They are big questions. Tonight is also about real evidence. That's going to be a focus, but also about the spiritual belief and its role in science. We think about the critical events that have happened in our human evolution, such as when we began to move, to walk, how our brains developed, when we developed the ability to critically think. These are answers that we can learn from fossil evidence. And also our roots of exploration, how we're actually continuing to learn, is changing. What are the big questions now, and how will some of those questions change? How exactly will we answer them? Are they going to be answered, or are some of these things unknowable? That's what we're going to talk about as well. Backstage, I was just talking with both Dr. Leakey and Dr. Johanson. I said, this is a very historic night. And Dr. Johanson immediately responded, in fact, it's prehistoric. Good point. Please warmly welcome Drs. Leakey and Dr. Johanson to the stage. Thank you very much. Thank you. Dr. Donald Johanson earned a PhD from the University of Chicago and has led field explorations in Ethiopia, Tanzania, and the Middle East. You may have heard his voice, seen his face as he hosted and narrated the Emmy-nominated PBS Nova series called In Search of Human Origins. He has co-authored 9 books, and he founded, as Ellen mentioned, the Institute of Human Origins, which is a human evolution think tank. Dr. Richard Leakey has been making international headlines for more than 40 years. His parents are the famous fossil hunters themselves, Louis and Mary Leakey, and Dr. Leakey was named as one of Time magazine's 100 greatest minds of the 20th century. He has authored over 100 books and papers, and is a professor of anthropology at Stony Brook University. He also founded Turkana Basin Institute in conjunction with that university. The way we're going to do things tonight, tonight's format, we're going to have presentations, about 10 minutes each, from both Drs. Leakey and Dr. Johanson. We do a moderated discussion for about 30 minutes after that. But we also want to hear from all of you. You may have note cards already. We'd like to have you submit your questions after the moderated discussion. We'll start taking questions from the audience. But first, warmly welcome Dr. Richard Leakey to the lectern for his presentation.
I thought I'd begin by reassuring you that this was the work of a doctor, not a colleague. I had some skin surgery, and unfortunately they were unable to remove the patch in time, and this was too. So bear with me. I know it's not pretty to look at, but it's a lot less troublesome, I hope, to you than it has been to me. The challenge is to put a lot of this into as short a space of time as we've been given, which is 10 to 15 minutes, and to recognize that one is then followed with somebody who I hope have equal difficulty in putting his words into 10 or 15 minutes, and to try to keep them separate but clear and in concord with what I believe we both share, and that is the fundamental importance of understanding human origins and the role that this must play in planning for a better world tomorrow. I think both of us and increasing numbers of colleagues around the world, and ones that I think we both interact with, are aware that there's far more importance to understanding the biological origin than there has ever been before, given the mess that the world is in, and the interconnection between our future and the planet's future, given climate change and some of the other threats that we face in terms of larger and larger human population and a rapid depletion of natural resources, particularly against the aspirations of 80 to 90% of the population of the world who want more and more resources to improve their standard of living. And I think there needs to be a lot more effort put into trying to understand the implications. Now, we're going to start out with Africa. I don't know if the lights are too bright for you to see that, but my own work has been concentrated within the Rift Valley, particularly around Lake Turkana. Much of my original work was done at Kubifora, which you see there on the right-hand side of the lake. We have built the new Turkana Institute up at Ilret towards the top of the lake. I have worked in the Omo River in 1967, and we also have an institute, a Turkana Basin Institute, on the left-hand side of the lake down at a place called Lodwa. The reason this is important is that we have fossil deposits and fossil strata that span an incredibly long period of time within one geographical area. And I suppose in some ways it's important because it will enable research into an area that has, I think, hitherto been largely ignored. And that is not so much the very early story, but the last chapters in the story. And that is the origin or the development of us today. This is just a quick picture to show you the Turkana Basin Institute, which is situated, this particular set of buildings is on the west side of the lake at a place called Turkwell. And this is now a place where dozens of scientists can interact, studying geology, archaeology, paleontology, human evolution, paleoecology, ecology, and contemporary land use patterns in this part of the world. I think more importantly is that we have a very, very high potential of recovering remains of humans and human activities that go back from, if you like, just and I never know what pre-biblical times are, but let us assume that we go with the biblical account of 4,000 or 4,004 years for the creation. We go to sites like this, on the east side of Lake Turkana, which speak to this migration of humans. And some of you will have already had the experience, some of you can have the experience of doing the gene test, where they take a swab of your mouth and they look at your genetic makeup, and all people who've done this can trace their origins more or less to a point in Africa, which you see in the middle there on the African continent. And it is within the last 65,000 years that the human population has spread across the world in different waves of migration, all the way across to South America, North America, and the Far East, and indeed Australia. The curious thing is that this happened. We know it's happened. It's well spoken of within the understanding of our genome and genetic records, mitochondrial DNA, and other studies. But we know very little about the people themselves to which this early population can be connected. Recent work has suggested that the contemporary languages of the world also can be traced back to between 60 and 70,000 years. And looking at that, that evidence, that it also speaks to an African origin for contemporary languages, which pretty well matches the genetic story itself. This is not to suggest that there weren't people before 65,000 years ago, or that those people couldn't talk. But contemporary people, whether they're from the southern tip of South America, or the heart of Australia, or the depths of Africa, or the northernmost area of human habitation in the Arctic, all of us share this point of origin, both in terms of our genetic story and in terms of our language. And one of the big questions for us to answer in the coming years is, who were these people? How do they relate to contemporary people in Africa, and how do they relate to the populations of spread out? What can we tease out of this record? At Turkana, we can start at just over 4,000 years ago with sites such as this, where we have an archaeological remains of some of the very early, or very late, if you like, archaeological record of funerary sites where numbers of people were buried in one place. Enormous blocks of stone were dug into the sand to mark these grave sites. They're associated with, in some cases, pottery, and before pottery you have very late Stone Age artifacts such as this beautiful ivory harpoon and many others. These range in age from 10 to 4,000 years. It's during that period that people moved from hunting and gathering to agriculture. We have got records in Eastern Africa of very early introduction of domestic animals, and I think it's fair to say that the probability now is that cattle were first domesticated in Eastern Africa, northeastern Africa. The donkey or the ass was domesticated in the same region. Sheep and goats were brought in. But there is a remarkable opportunity in the Lake Turkana Basin to look at that and tie the cultural development and some of the other behavioral activities with what we're finding from the study of DNA and other lab-based studies. We have good fossilized remains of these early people. This is a skull that I found many years ago, and what is of interest to this is you'll notice that it's elongated from front to back, and this is a skull that clearly shows it was bound 4,000 to 5,000 years ago, and this is reminiscent of binding skulls that you see in Lower Egypt in the same period. And there's some very interesting links between Lake Turkana and the northern part of Africa in pre-Pharaonic Egypt that links through the Meroe and the southern Sudanese settlements. And there does seem to be a clear link between the north of Africa down to Lake Turkana, and many people would ask why, and the answer is that Lake Turkana was the source of the Nile until 5,000 or 6,000 years ago, and it was an obvious waterway on which people could follow, moving out of the center of Africa, probably not once, but many times. And Lake Turkana is particular because it does offer a continuum of archaeological and fossil records that goes not only from the present, but all the way back into the pre-human phases, whichever way you want to define that, and Don will talk more to that, into the origin of the apes and the origin of the primates, and we go all the way back to dinosaurs. So there's a remarkable possibility of understanding this. Now, I've mentioned that elongated skull is Homo sapiens, 5,000 or 6,000 years old at most, but we also found at Lake Turkana what turns out to be one of the oldest examples of Homo sapiens. This was a skull that I'm looking at here, which we found in 1967. This particular skull was found by a colleague, Kamoya Kimeo, who found many of the other discoveries that we found, and it dates at between 190 and 200,000 years. It is anatomically a modern human, but it is not of a population or a time range that links it to us. One of the questions is, if there were Homo sapiens about in Africa 190,000 years ago, and we know that they moved beyond Africa, why did this more recent population, 65,000 years, have such success in driving them out or driving them to extinction? What was it that caused that? A big question. Language may have something to do with that, but again, one of the questions we can probably look to answer. I think this is important stuff, and I will allude to this just very briefly here, given the constraints of time. I have devoted, as Don has and many others have done, to trying to persuade people of the truth and the validity of the story of human evolution. And we've tended to pick up or find, if we're fortunate, bits of bone that are fossilized 2 million years ago, 3 million years ago, some 3.5 million years ago, which even amongst us, where we have some argument as to whether they fit here or fit there in this enormous story. And it's not surprising that lots of people don't believe us, because these don't look like people. They look like something that isn't a people. And so I've thought, well, maybe we should turn this around, and we should start with us, and we should go back that things are clearly us. And the further back we go, the less like us today they are, but they're still very similar to the examples that we found that came just after them. And so we unravel the onion, if you like, from the outside inwards rather than from the in to the outside. And I think there's a lot of merit in doing that, because you can take people along with persuasive evidence that we're dealing with humans, and pre-humans. And it's only when you get really far back that people say, well, wait a minute, this no longer looks like us. And you say, but it looked like what we showed you just before, which is slightly younger, and that looks rather like something that was a little younger than it, and something was a little younger than it, looks quite like it, until you end up with things that are clearly us. And I think the validity of that approach needs to be tested, but I think people will find that much easier to understand and to swallow, particularly when this is linked to the archaeological story. And these examples of 195,000-year-old Homo sapiens that we found in Ethiopia on the Omo River, other examples have been found in northeastern Ethiopia under expeditions that Tim White and other people have conducted, it's very clear that Homo sapiens was around much of Africa, at least on the eastern side, from a long time ago. We then find things like this. This is also a Lake Turkana discovery. It's badly damaged in the frontal area. The face is gone, the brow ridges have gone, but it's got a big skull. And you look at it and you say, well, yeah, that looks like a human skull. And I put some other examples of that sort of time frame on the left and below it, where they're more complete. These probably go back between 200,000 and 400,000 years. We haven't got precise dates on them, although the one from Lake Turkana may well be dated in the next few weeks as a result of new techniques that have been developed. But it's very clear that primitive Homo sapiens, or pre-sapiens, anatomically primitive sapiens, whatever you want to call them, and you can get into huge arguments about what you call something, but there were things around that looked like us, large brains, but possibly not quite like us in terms of the finesse that we see in fully modern people. These examples on the screen link to us, but you're now back 350, 400,000 years. And I think the connection between them and us can be well demonstrated on anatomical grounds as well as archaeological grounds. If you then go further back, and this is an example here that I will show you, to Homo erectus, you say, well, okay, if the other ones were us, or our ancestors, this clearly is true, at least in the cranial features. And if you look at the skeleton, and this is the so-called Turkana Boy, which is an almost complete skeleton, lacking hands and feet, but most of the skeleton is represented by original pieces. There's a certain amount of reconstruction you can do, but we have the rib cage, the collarbone, the arms, the head, the jaw, both limb bones on both sides. And you can say, yes, this is, if it had come in here tonight, it probably would have been acceptable if he had been clad in reasonable clothing, although whether he would have understood what Don's going to tell you, or let me say what I'm going to tell you, is another question. But that's not a problem that he would have had alone. We must accept that. But the point is, this is not Homo sapiens, but this is 1.5 million years ago, more or less. Now, if you started with that, people are going to say, but he had a smaller brain than we do. Yes, he did. But it's not that much smaller than what comes slightly later in time. And so you can begin to piece this together and begin to see things that are real. And you can, in fact, go back to an earlier record where fossils like these have been found that go back to the early part of the 1800s. And here are some of the early fossils that were found. You've got the Gibraltar skull discovered in 1848. Some Neanderthal examples there, the Trinil fossil found in 1891, which are variously assigned to either Homo erectus, late Homo erectus, primitive Homo. You can take whatever name you like, but they're all characterized by looking more like us than anything else. And the link between these late erectus, sort of primitive Homo sapiens, whatever you want to call them, the ones with the large brains, the large brow ridges, is one of the questions we have to answer. Are these uniquely non-African? The skull from Lake Turkana and other parts of Ethiopia suggests that it's not the case. How do these all link together, and what is their relationship with what comes much later on, and that's the 200,000 anatomically modern humans? There's some very important questions into which you've got to insert other considerations, like, given that we are what we are, what is it that we are? Well, we have speech, which doesn't fossilize, although the linguists believe they can take this back. If you could take it back to 65,000 years ago, as I mentioned earlier, does this mean that there was no speech before 65,000 years ago? Or was the speech that came about more or less then so much more sophisticated in terms of syntax that this gave them a biological advantage that would enable them to out-succeed other populations that had spread around the world in the period prior to 65,000 years ago. Can we find answers to those sort of questions? Can we link perhaps what we're finding in the genome to we've now got good evidence of the DNA of Neanderthal. Can we find fossils in Africa that go back 40, 50, 60,000 years ago and find some genetic material in those? And if we can we tie that into modern populations? Can we tie that in to some of the things that are being found in other parts of the world? I think there is an enormous potential to unravel over the next decade or two information about us that has eluded us, partly because we weren't looking for it earlier on. And many of you will recognize that anthropology, really since the early 1900s, avoided dealing with modern humans, and particularly by the 30s, anthropologists were worried about dealing with modern human anthropology because of the use of studies in terms of race-related issues, the origin of Nazi attitudes, the superiority of one race over another race, the whole issue that people were different and could be established on a scale that went up with the blue-eyed Aryan Caucasian at the top and everything else sort of falling away below it. Absolute nonsense, humbug, but had currency in the early 1900s until the end of Second World War II. I'm afraid there still seems to be some of that resurgence today, and I think we need to be careful that we don't get trapped in an argument that takes us back to an attitude of racist, although I don't think they can use the fossil record to support them. They would use more political arguments. In addition to Homo sapiens, pre-sapiens, erectus, late erectus, early erectus, there are all sorts of other fossils. There's these things we call Australopithecines, paranthropines, there's things that have different species names. Some are more complete than others. We've got a good assemblage of skulls. We've got some partial skeletons, some remarkably complete skeletons. There is really quite a remarkable record, and one which we shouldn't gainsay in terms of its lack of specificity towards understanding our condition. But there is far too much to deal with in a short period of this time, and my brief was to talk about the excitement that I feel for looking at the last 200,000 years, and particularly looking at it in a place like Turkana, where so much can be found. There is obviously still a hunt going on for some of the bigger questions. When and why did humans first appear, or pre-humans first appear? What is the origin of bipedalism? This trail of footprints that my mother discovered at Laitoli in Tanzania, the people who are thought to have made them, that were called Australopithecus afarensis, artist's reconstruction of this loving couple walking across the African plains. Well, yes, it's one interpretation. The footprints are real. The artist's work is real, but the facts upon which it's based may not be as strong as it suggests in terms of dark hair around the pubic area and pendulous breasts and affectionate hugs and things like that. There's a lot of room here for interpretation, but there's a lot of room for interpretation in all sorts of things. And I feel that at this stage, I will ask my friend and colleague, Don Johanson, to try and sort that out for you. And I'm sure he'll do a good job, and we'll take some questions later. Thank you very much.
Thanks, Richard. Well done. I've got to try to find my PowerPoint on here, which seems to have disappeared. There we go. And down here. Great. It's a long way from hunt and gather to point and click, so sorry that took so long. Thank you very much, Richard, for setting the stage for one of the more interesting and perhaps a little more complicated parts of the human career. But before I begin, I want to, on behalf of Richard and I, thank the American Museum of Natural History and all of the wonderful people who have come together to organize this prehistoric event. to urge Richard and I to talk about the state of the field, what we know, what we don't know, where we think we're going in terms of research. And I couldn't think of a nicer, more appropriate place to have this. I love coming to New York. I love speaking in this hall. I have done that on a number of occasions. And Ellen, you and your team are just number one. Thank you very much indeed. Now, we didn't entitle our presentations, but when I was behind stage, someone said, have you titled your presentation? And I said, no, but I could have called it Becoming Human. And they said, why Becoming Human? I said, because when you look at the world, wouldn't that be a great idea? To become human? As you can tell already from Richard's presentation, we are both very Afrocentric, and rightfully so. Charles Darwin, Thomas Henry Huxley, and others in the 19th century, even before we were born, even before anybody found a single fossil in Africa, because of the similarities between ourselves, and particularly the chimpanzee, but the great apes in general in Africa, that Africa would indeed be the continent where we began. And we travel around Africa, and we find places calling themselves the cradle of humankind. It is really Africa that is the crucible of humankind. This is where the beginning of our unique zoological family occurred. It's where all of the major steps in the human career, if we can say that, made their premier appearance: upright walking, enlargement of brains, manufacture of stone tools, perhaps origins of language, bodies of modern proportions, and so on. So that the prognostications that were made are certainly correct. And that was at a time in the 19th century, you might remember, when we were so Eurocentric. We were so Eurocentric, looking for the origins of humans in Europe, because everyone believed that Europe, and these, of course, were all European scientists, believed that Europe was the finishing school. That's where we finally made it over that Rubicon from primitive to modern peoples. And the work that all of us have done over the last 40 years or so shows us clearly that it was Africa that was the crucible of our origins. So as Richard said very clearly, and I will say it slightly differently, no matter where you grasp a branch on the human family tree, the roots lead back to Africa. We are all Africans, and we owe our origins to Africa. I thought as I was putting this together what it was like when I landed in Nairobi in 1970, in mid-June, on my first experience to the Great Rift Valley. This is what we knew about human evolution. It looked pretty easy. There were about 5 species of the genus Homo, the genus that we belong in. There were 3 bona fide species of Australopithecus. So it wasn't too difficult to kind of draw lines between these things and to try to understand perhaps some of the genetic relationships. But today, things have become, as you will see, a little more complicated. Because of the work that we have done and ongoing work, in fact, there's a new species that was just named recently, Australopithecus sediba, that you will be hearing a lot more about over the next few months. But as you can see, a number of new species and surprises, like those little hobbits from Flores, have been added to the genus Homo. There are a group, actually a fluorescence or adaptive radiation, you might say, of Australopithecus here in orange and in yellow. And most importantly, digging deeper back into the past, getting closer and closer to that common ancestor that gave rise to the African apes as well as ourselves. We have a group of what I've called pre-Australopithecus. And here we have seen over the last few years the naming of not only a number of new species, but a number of new genera, such as Ardipithecus, Auroran, and Sahelanthropus. This is a box, an orange box of a few species and genera that are very difficult to put into context. These are creatures that are much more ape-like, much more primitive-like. They look less and less like us. There are certain Australopithecus fossils that look more like us. And when you get to early Homo, of course, as Richard was saying, look much more like the person sitting next to you in this room. Now, when we look at the origins of Homo, we know that this happens somewhere between 2 and 3 million years. But this is one of the real periods of non-fossils where we really don't have good evidence for the earliest Homo. We can take Homo back to about 2.4 million years, a discovery that was made at the site where Lucy was found, in the upper strata of the Hadar Formation. This is a jaw that clearly belongs in our genus. So the last time Richard and I spoke, this 2 to 3 million year time range was pretty empty. But we've now narrowed it down to about 600,000 years. Somewhere between 2.4 million and 3 million years ago or so, we see the origins of our own genus. And very quickly thereafter, we see, again, a diversification, sort of an adaptive radiation into a number of different species. And how we connect all of these up is not what we're going to address tonight, but to show you that there really is a significant diversity, not only in Australopithecus, as we've known, but also within our own genus. One of the interesting things about Australopithecus that I wanted to touch on was something that was in the news this week that relates specifically to these megadont forms, these very large toothed forms like Australopithecus boisei, Australopithecus robustus. There was a study published early this week that was based on isotope studies that suggests that most of these creatures were mostly eating grass and sedges. This was a group of hominids that lasted from about 2.6 million years ago to about 1.2 million years ago, a very successful adaptation. But it was a specialized adaptation to a special kind of herbivory. And all of these creatures went extinct. This is a very important message for all of us today, because we know that not every single species we find is an ancestor to modern humans. And we have to decide and figure out which species met the grim reaper of evolution, extinction, and went nowhere, and what other species survived the trials and tribulations of evolutionary and climatic change and evolved into ourselves. But this is an idea that goes back to the 19th century, that it was a straight march from ape to angel. The ape is always some lowly African creature, and of course the angel is always a white European male at the end of one of those depictions. Why it's a white European male? Because white European males draw those things. So, in fact, what we are finding is that many more species went extinct than survived. And this is an important lesson for us when we think of evolution and the evolution of all animals, but particularly of ourselves, that it was not a straight line. There were many false starts. There were many side branches that died out. Of course, if I didn't say a few words about my oldest girlfriend, I'd be in big trouble. Here is, of course, the Lucy skeleton that was found in 1974. She continues, her species, Australopithecus afarensis, continues to be a very important species because now we have more than 400 specimens spanning 800,000 years of time. So we can say something about not just how males and females differed, not just how young and old differed, but how this species varied over 800,000 years of evolutionary time. And afarensis becomes an incredibly important reference species for interpreting other discoveries. Now, I was on an airplane not long ago, and somebody asked me what I did, and I told them, and of course they all thought I was Richard Leakey when I told them that I found Lucy. And so at that point, he said, well, did you ever find anything else? And I said yes, and I actually don't talk about that a great deal, that we now have over 400 specimens. We have complete female skulls. You see Lucy's skull wasn't very complete. We have complete male skulls. We have bones literally from every single part of the skeleton. And afarensis has become one of the best known, if not the most completely known, early hominid species from Eastern Africa. And here again, this is my reconstruction of Richard's mother's discovery when Mary found this in the mid-1970s. This is this is one of the true wonders of the very, very, very ancient world. Two of Lucy's species were walking on what is today the Serengeti, and there was a major volcanic eruption. That eruption blanketed the landscape like a snowfall, and fortunately, at least two of our ancestors walked across there, a large individual and a small individual. I don't know if they were the honeymoon couple you saw earlier. or it was mom and a kid, or mom and dad, or whatever, but they left footprints. And what was important about that was we were in the middle of one of the most contentious arguments, and I know Richard's sitting there saying just about everything either one of us has said thus far can be debated till it's almost dead. But we were in the middle of an argument about whether or not Lucy's species was capable of walking upright. And we based those assumptions on the skeletal material. And here, Mary found a trail of actual footprints, 3.6 million years old, and bones of Australopithecus afarensis in the same stratum. And we could take a close look at one of the most important and diagnostic features of the entire skeleton, which is the position of the great toe. You know, when you're out in Southampton over the summer or whatever, and you walk on the beach, look down, you'll see your great toe as the propulsive part of your foot that leaves a diagnostic impression. If you were a chimpanzee, it would be divergent like that, and it would be very different. So this was extraordinary evidence, unanticipated, one of the great surprises, and as I said, one of the great wonders of the very ancient world. Let's take a quick look at pre-Australopithecus, Auroran, Ardipithecus, and Sahelanthropus. There are fragments. They're not very well known. Fossils get more and more difficult to find the deeper we go into the past. The material from Auroran here, the two thigh bones that are shown, show indications in the top end of that bone that they were bipeds. So it means that bipedalism probably goes back to at least 6 million years. There's one little toe bone from this species up here that looks like it's from a foot that was capable of walking like ourselves. And I haven't shown it here, but Meave, who couldn't make it here, Richard's wife, made some marvelous discoveries of fossils at 4.2 million years of a shin bone that show that these creatures were clearly bipedal. There's a great deal of discussion about Sahelanthropus, a specimen from Chad, north-central Africa, whether or not it really belongs on the human family tree rather than the ape family tree. And the most recent, which you've all heard about, Ardipithecus ramidus, was found way back in 1992 and only just published 2 years ago. And this is where I'm going to make a few comments, and then we're going to go to question and answer. But Ardipithecus is an extraordinary discovery. It's about 4.4 million years old. It belongs, as the discoverers have called it, Ardipithecus ramidus, in a new species. It's about 200,000 years older than that tibia that Meave found, which is called Australopithecus anamensis. It was a remarkable job of putting these bones together, of reconstructing these. Much of the reconstruction was done in virtual space. These were not bones that were glued together so much, but they came up with a beautiful partial skeleton that you see here, and a couple of things that will catch your eye immediately. One is the very divergent great toe that you see here, very different from what you see in the Laetoli footprints. But upon more detailed inspection, particularly the lack of a chimpanzee or an ape-like interlocking of the upper canine with the lower jaw, which is more like us and less like apes, and some hints in the pelvis that perhaps this creature was quasi or facultatively bipedal. They have suggested, Owen Lovejoy and Tim White, that this is a direct ancestor to later Australopithecines. And they have reconstructed, as you can see, Ardipithecus upright. You can see the long, very powerful grasping hands and the very divergent great toe, which, as I said, is even more divergent than what we see in chimpanzees today. And the reconstructions that have been done of Ardipithecus show this upright posture. But in reading their papers, they make a great point about the fact that this was in the trees quite a bit of the time in a quadrupedal sort of stance. And I recently had a reconstruction done of Ardi in the trees. You see the grasping great toe, you see the large, powerful hands, and they suggested that it was quadrupedal, four-legged, what they call pronograde, that it was on tops of the branches rather than swinging below the branches. There are lots and lots and lots of questions about Ardipithecus in terms of its position. Should it even be on the human family tree rather than the ape family tree? It looks like it has certain features, like in the dentition and in the pelvis, that would make it a hominid. If it is, does that necessarily make it an ancestor to later hominids? Could it have been one of those evolutionary experiments where bipedalism may have perhaps been experimented with in an arboreal habitat? How do you explain a creature that's so comfortable with quadrupedalism becoming bipedal on the ground? Lots of interesting questions, lots of debate, and the debate certainly has begun. I'm going to close with a reconstruction that we did for my Nova series of Lucy coming down to the lake and drinking, and close with a thought I had earlier today. What do all these bones really mean to us? What do they tell us? And I think each time we hear the term missing link all the time. I like to look at them as every time we find one of these bones, it's a link, but it's a link to the natural world. It's a link that reminds us, Homo sapiens, who I think probably should be better called Homo egocentricus, all the time we spend thinking about ourselves. It reminds us that we are part of the natural world. We are not super-organic. We are a product of the same evolutionary change that all other creatures on this planet are. Yet we have inherited an awesome responsibility, and it is time to take that responsibility seriously, to make decisions that will not just be good for ourselves, but for all of our fellow travelers on this planet, so that we can leave descendants ourselves and look back on their ancestors. Thank you very much.
It's wonderful. I want to get right to it because we obviously have a lot to talk about. So let me start, Dr. Leakey, with you, something that you brought up during your talk. And I mean this in sort of the most overarching sense possible, but why does it matter to people living in the world today, people in this audience, where we came from?
I think partly my answer would be that we are curious. We have a mind that thinks. We want always to know why. If you ask why, you want to know more than why. And I think with an intelligent mind, we need facts about the world that we're part of. And I think that in many ways, the origin of all religion was an attempt to answer that question before there was a scientific basis for finding answers to that question. And I think we do need to know why. I think perhaps more importantly than that is with the prehistoric record that we have, not only of us and our immediate and early ancestors, there is a record of many other species as well. And what is very clear is that extinction is, if you like, a more frequent event as we look back from today, than speciation. And the vast majority of forms of life that have lived on this planet are now long since gone. And there is absolutely no reason for us to believe that we are not equally available as a candidate for extinction. Now the question is when, and the question is perhaps why. But I think we need to understand that we are a biological entity more than we are anything else. And by looking at the prehistoric record and looking at the biological record of evolution that is now, I think, manifestly richer than it has been at any time before, I think we can put ourselves in a position where extinction and our actions on this planet, as Don said in his concluding remarks, are very significant as to where we're going. And if not where we're going as a large-bodied primate, what we're doing to other organisms that could cause our extinction, even if nothing else does. And you know as a medical man that the misuse of antibiotics, the misuse of biological agents could seriously affect the future of mankind in terms of the species that we now know and its population size on the planet.
It's incredible to think about, and Dr. Johanson, you mentioned during your speech the grim reaper of human evolution. So building on what Dr. Leakey has said, I mean, are there certain things that we have learned from our past that give us some idea of where we're headed in terms of our future and evolution?
Well, the one thing, we keep returning to the same idea of extinction. We learn, we're humbled by the fact that there were so many beginnings and yet only one lineage that did survive. And we should treasure that. We should really treasure that and do everything we can to reward the natural world that created us. I think that what this does is it firmly puts us in the center of, people ask, who is our creator? How were we created? We as scientists, Richard and I, have come up with scientific explanations that rely on traditional natural selection, evolutionary change. And it means that we are so closely tied to the natural world She is our creator. And we should be more humble about our position in the universe. And we should be making decisions that will protect our creator rather than disturb our creator. Because ultimately in this great web of interconnected life, where you do something someplace, you will always feel a reverberation somewhere else. I was in Omaha last week, and someone came up, and her first question was, what do you think about the millions of dollars that are being spent on preserving this one bug that's facing extinction out in our farmland? Should we be spending billions of dollars or millions of dollars doing this? And I said yes, because we don't know how important that bug is going to be in the future. We don't know if it's an important fertilizer of a particular prairie grass or whatever. So while we can, as evolutionary biologists, with a very historical science, look to the past and learn some lessons, we should be able to use those to understand how we fit into the natural world, how important our impact is, and what the consequences are when we begin to rapidly degrade the very natural world that created us.
Let me just put another turn on that, because I think it's a very important question that we both feel should be addressed tonight, and that is, there are a lot of people in this country, a lot of people around the world, who find it much easier to live with a faith-based explanation of who they are. I have no problem. If that's what you want to do, if that's the way you want to live your life, no problem. Where I take exception as a citizen of the world, is that faith-based explanations should not be forced to the exclusion of biological-based explanations. And I'm seeing in the developing world in Africa, I think it's true in many parts of the developing world, we're seeing science get edged out because some people don't believe in human evolution. And I think the teaching of science is fundamentally important to the future of our species. And I would go so far as to suggest that had Charles Darwin not suggested that we had evolved, but that only pigs and elephants had evolved, this problem would never have arisen. But it's because he tampered with the image of man, suggesting that it had changed. And if you go back to the Judeo-Christian concept that God created us in his image and us being this image, you've got a little problem.
I think I know, let me tell you about a Gallup poll from 2010, sort of building on this point. 2010 December, 40% of people polled believe that God created humans in their current form. 38% believe that God guided that creation. 16% believe that God had no role, and 6% apparently were asleep during the poll. I think I know the answer. Which category do you fall in?
Pardon me?
I think I know the answer to this, but which category do you fall in?
Yes. I don't believe in evolution any more than I believe in gravity. Evolution is a fact. It is the best explanation for the diversity of life on this planet. It does not take belief because it can be investigated through the scientific method. Observations can be repeated. It is as much as a powerful a theory as is the theory of gravity for explaining, in this case, the diversity of life.
Over the last 40 years, almost since you discovered Lucy, your team discovered Lucy, the numbers that I just cited you really have not changed that much. Does that surprise you? Why do you think that is?
The figures have not changed so much?
That's correct, in terms of that polling data, in terms of the percentage
That's
of people.
true. And I think that it is our duty as educators and people like Richard and I who lecture widely to go out and educate people and to help them over this problem that they have with evolution and religion. You can be a very religious person, like Francis Collins, who was head of the National Institutes of Health, a good friend of mine, and who's a born-again Christian. And he is as good a scientist as anyone. And believing in a creator, whoever that creator is, he, she, whatever, does not really influence the way you do science. And Francis has shown this clearly. And there are scientists who are evolutionary biologists, who have other kinds of religious beliefs, and religious people who are not scientists, who say, this is the naturalistic explanation for how we came to be. And I think, in fact, it does have something to do, as Richard said, with the lack of education in our country and in many other countries, that it is not taught in schools. Today, in 1925, this is the anniversary of John Scopes being arrested today for teaching evolution in Tennessee. We've come beyond that, but we still have a long way to go. And I think that it's incumbent on our educational system to teach this and to teach this at a very young level. Young children in what I call grammar school when I went to school, but elementary school, think that evolution is a fascinating idea. They love to understand the interconnectedness of life. So I think that it's really incumbent on all of us to do whatever we can to educate people about evolution.
But let me just add one point, and I'm going to be a little naughty because I generally like to be a little naughty once or twice in an evening. But the poll numbers you suggest relate to a poll taken in the United States, and as great a country as you are, it represents at most 300 million people. The world is about 7 billion, so the species isn't doomed by your poll.
But fair enough.
Sorry.
Besides education, though, what other cultural factors are at play here, though? Because I think it seems easy enough to suggest that more education needs to be done. Some of the talks that have been presented here over the last couple of days have been streamed to schools, for example. What other cultural factors do you think are at play here that has made these numbers hardly budge over the last 30 to 40 years?
It's very difficult to be sure, but I think truly the standard of education in developed countries are not as good as they may have been. And I think we're seeing a similar sort of problem, not just in the biological sciences, but I think in many of the sciences. And I have experience recently of working as a result of my connections with a university in the United States, the Stony Brook University. I mean, basically, more and more young people are being shown how they can access through the web information, but because it's there, they don't learn it. And because it's there, they don't interconnect it. We're not teaching people to think, we're teaching people to push buttons to get information to answer questions in school and questions in college. This to me is wrong, and we need to recognize that unless young minds can be encouraged to think, how can they think later? And if they can't think later, I mean, don't worry about us, but we as a species of 7 billion are dependent to a very large extent. 90% of the population of the world is dependent on basically 3 crops: corn, rice, and the cereal wheat, in one form or the other. The genetic base of those highly productive, yielding crops has been narrowed down by the clearance of areas to grow them, with very little of the natural base from which they were genetically derived in the breeding programs. What happens if a pathogen develops in corn or in wheat or in one of the rice, as has begun to show up, where you can eliminate in a few years the entire production of cereals around the world because of wind-blown disease or treatment-resistant disease that would affect those crops? What sort of starvation are we looking at? And we need young people in India, we need young people in Kenya, we need young people in Brazil who are up to the challenge of understanding this could happen and up to the challenge of making sure that it doesn't. Let's not worry about us per se, but us in terms of the way we live and how we're living has to take in the biological perspective if we're to survive in the form that we know we are today.
Dr. Johanson, so you've been busy since Lucy, as you mentioned. Good to hear. You just got back as well from Tanzania and South Africa. What are you working on now? I mean, when you're thinking about this field and your work, what do you do when you go out on one of these trips? What is your process? Are there specific questions that you're still trying to answer?
I think there are 2 major areas that are most interesting to me and to the Institute of Human Origins, where we have a number of scientists working in Ethiopia and South Africa, and that is one of the topics that Richard touched on, which is the emergence of Homo sapiens. And what prompted that appearance of modern Homo sapiens? When did it occur? Where did it occur? We have a scientist who's working in South Africa. I visited his site recently, and there's good evidence there of tools that don't show up in Europe till about 40,000 years. He's finding them as old as 75 or 100,000 years. Finding innovations such as heat treatment of stone for the manufacture of stone tools that didn't appear in Europe till about 30,000 years ago, that first appeared in southern Africa. the use of ochre in body decoration, for example, the emergence or glimmerings of art, one of the things that distinguishes us. So I think that that's one area that we are spending a lot of effort on, trying to understand the oldest Homo sapiens, when we came out of Africa, but when those innovations occurred. And they seem to be tied to climatic changes. At around 200,000 years ago, there was an extended period of prolonged, very cold climate that is coincident with the emergence of our own species, and as well as coincident with the emergence of a number of these innovations. The other area where we work in Ethiopia is targeting sediments that are between 2 and 3 million years. I alluded to this in my presentation, that we are very interested in trying to understand the emergence of our own genus. We know a great deal about Australopithecus. We are beginning to know about some of these more ancient areas of human evolution, but we really would like to know a lot more about the origins of our own genus Homo.
Dr. Leakey, you talked about this a little bit in your speech, but what do you think makes us human? I read this article recently about the fact that when we evolve, is it perhaps in the future this idea that human beings, the way that we know human beings, could be replaced by computers? I mean, could they do what we human beings do? Which raised the question in my own mind, what makes us human beings?
I think that the two questions that I'd like to address. One is one that we are guilty of often saying, that we separated from the apes. And that gave lie to the search for the missing link, this common ancestor between apes and humans. And I think one steps back a little bit in later life. One realizes that we actually haven't separated at all. We are apes. We're just another species, another complicated group of apes that walk around on two legs. Many of our closest relatives have become extinct and we have survived. But there was no sort of omega moment where, wow, suddenly we have something completely new. It was a very gradual, different process. So evolution didn't cause that dramatic origin of humans. And I think what makes us human depends where you want to cut it. Clearly, our use of technology today and our dependency on the lifestyles that we've grown accustomed to, whether it's the very poor or the very rich, is part of what makes modern humans in the 21st century, and there's very little comparison to them and people who lived in the 16th century. But they were humans. Does humanity require that we have the capacity to score highly in the Mensa tables or with IQ tests? Well, there are clearly people who can't do the Mensa or the IQ test for a variety of medical reasons, and yet they're perfectly human. So how do you want to cut this? Where do you want to draw this line? Is it because we have a large brain relative to body size? Well, yes, but if you start looking at modern humans in anatomical departments of medical schools, as you probably know from your own training, it's not always the bigger brains that are the smartest people. It doesn't work as simply as you would like to suggest if you say big brains are important. These things are all relative, and I have long toyed with this idea that somehow technology is an important part of being human. But when you have several, as Don has explained, different species of hominid, whether they're Homo or Australopithecus or whether they're pumpkins and apples, I mean, it doesn't really matter what we call them, but there were several different things going on at the same time, and you have evidence of basic crude technology in terms of cutting objects. Are we sure who made those tools, who accessed the meat diet through those tools? Do we rule out the other candidates? Or are we not being driven by a desire to simplify to a point where we're doing this? So is tool making necessarily a criteria for being human? And I think one would have to say probably not, unless you redefine tools. And so this whole thing starts to get very complicated, and I think it depends where you draw it. But I think one of the most fundamental points at which this story might start is bipedalism, and I think this search for the first biped, if you like, which Don alluded to in terms of the growing debate about Ardipithecus and whether it had a toe that prevented it walking on two legs habitually, or whether it was clambering around in the trees on top of the branches and sometimes was upright hanging onto the center trunk. Good heavens, we could talk about that forever. The point is that bipedalism does seem to set us apart from the other apes. And it's not just that they walked upright, but they adapted their hips and their back and their limb bones for a habitual upright bipedal posture. That is, if you like, the beginning of this story. But I think a much more interesting part of it, well, not more interesting, but equally interesting story, is when did we learn to use language to do things that nothing else does? When did we put syntax into our... When could we express ideas that weren't simply go, come, stop, run, danger, food, but actually starting to discuss where the danger might come from and where the food might come from in the next season, and how we relate? When did compassion come about? When did we start worrying about the survival of an individual? Empathy, if you like, or compassion. Well, it's something that's very simple. I never really thought about it. But as some of you know, I lost both legs in an accident some years ago. And if you're a two-legged creature and you have no legs, you don't go very far. Even if they give you one artificial leg and you only have one leg, you're still totally dependent on somebody feeling sorry for you, or caring for you, or thinking they can get something from you if you get better. Whatever motive you want to apply. But being a uniped is no better than being a noped. Whereas if you're a chimpanzee or a baboon, or a lion or a dog, and you have four legs, you can lose one and do perfectly well. You can actually, in case of domestic dogs, lose two and still do pretty well, provided they're diagonally removed and not all on one side. Now, once we became bipedal, and this comes back to the story, bonding and social interactions take on a totally different, not just meaning, but value. And I do not believe bipedal primates could have survived unless they had, in addition to being bipedal, changed the way they think in terms of altruism and in terms of social networking and social connections. And it's all very well to say, you know, we love the mother of our children. The hell we do. We do as long as we can have children with her, but once they're born, men tend to take off. So I think that's a primate character. And I don't think sex is the basis of bonding. I think it's much more fundamental. It's survival.
Your question of what does it mean to be human has been addressed by anthropologists for centuries. And some people say you're not human until you're bipedal. Other people say you're not human until you start making tools. Some people say you're not human until you have an enlarged brain. And that you don't immediately become magically human by stepping into this evolutionary tunnel as an ape and walking out as a fully formed human. So that these are things that accumulate over time and make other things possible. And ultimately, of course, the thing that makes us most unique and different from all creatures is the ability to think symbolically. I think this is really the defining feature, something that we don't have paleo tape recorders. We don't know what paleo language was like. But when we do encounter early human ancestors, maybe as old as 75,000 years, who are beginning to leave their mark by engraving a piece of ochre that ultimately evolves into something like what we see in these marvelous rock paintings that are all over South Africa, East Africa, and of course the ones we know best in Herzog's new film, the Chauvet film, in the Upper Paleolithic of Europe. That is the final major distinguishing feature that makes us so different from all other animals. But yet, on the other hand, the more we study the apes, as Richard said, we've been called the bipedal ape, the naked ape, the stupid ape, or whatever. But we're finding by studying our closest relatives that it blurs a little bit, that apes, particularly chimpanzees, do make and use rudimentary tools. Mm-hmm. They use rudimentary tools to crack open nuts. They use rudimentary tools to termite fish, for example. They do show signs of compassion. There are apes that Jane Goodall has studied where a young baby has died from grief over the death of its mother. So these sorts of things all have their glimmerings, probably much deeper in the past than we ever thought. And that is something to look at on the other side of this coin. Not so much what makes us human, but are there glimmerings and indications from studies of our closest relatives that this is part of a continuum, that it isn't a magic moment when a finger comes out and touches us and makes us human. This is a continuum. This is an evolutionary change and tinkering over time. And that, again, is something that gives us a much better understanding of who we are. We are not separately, sort of uniquely brought about. We are part of this continuum. We are one branch on it, and we can look at our closest living relatives, the African apes, and see glimmerings of what it might mean to be human.
We got a lot of questions from the audience here, so I'm going to try and get to as many of these as I can. And let me start with you, Dr. Leakey. Do you think the discovery of life beyond Earth will change opinions about the origins of life here on Earth?
Do I think that the discovery of life beyond Earth
Change opinions about
would change the way we think about life here and our origins
the
here?
origins here on Earth? Yeah.
Well, absolutely. I mean, I think the arrogance of thinking that we're unique would be dealt a swift blow. And I can't wait for that to happen. I think it would be a wonderful thing to demonstrate beyond any doubt. I mean, I think there is already sufficient reason to believe there is life, whether it's life equivalent to us, and we're now falling into the trap that we think it'll be life like we have here. Let's hope not. But that there will be life in other planets, unless you're prepared to be as arrogant as we have been for the last few centuries, surely it's there. Surely it's going to be different. Surely it's going to be difficult to access it. And, you know, the analogy of an alien spacecraft going by and looking at the Earth and said, should we drop in? They say, no, that's a failed state. Let's move on to somewhere better. I think is a very good one.
Let me keep going. I'll just get to the next question. How or why did Homo sapiens develop in Eastern Africa and not elsewhere in the world? And maybe you could extrapolate to other species as well.
Well, I think the conditions in Africa, both environmental and biological, were perfectly poised for the emergence of Homo sapiens. And whether it happened in Eastern Africa or Southern Africa, we know definitively that it happened in Africa. It did not happen in glacial Europe. It did not happen in Asia. This is where we see things like Homo erectus and Neanderthals. Neanderthals are a wonderful example here of kind of understanding the origins of species like this, because Neanderthals and we had a common ancestor. It's sometimes called Homo heidelbergensis, which is a strange name to use for the origins of sapiens in Africa. But they were isolated genetically and environmentally in Europe and evolved into their own definitive species. We evolved in a tropical environment under very different conditions, under which hunter-gathering, for example, was something that was of very high selective value, because they not only subsisted like Neanderthals did solely on meat, but we subsisted on a very mixed diet of hunting and gathering. I think that the factors in Africa were very conducive to the origins of Homo sapiens.
I'll get to this question with you, Dr. Leakey. If evolution never ceases, then what do you think humans will be like about 1 million years from now?
Well, 1 million years from now, I think the process of extinction is likely to have
I was afraid you were going to say that.
Required further consideration. I mean, I think one needs to be very careful to understand that evolution doesn't happen because the clock is ticking. And I think there's a misconception that Darwin suggested that life will continue to change, irrespective, provided there is time thrown into this. It's far more important to recognize that for evolution to happen, or physical change to happen, or adaptive strategies to take effect, there has to be an underlying fundamental environmental pressure that drives organism to try doing things differently if they're going to survive. And I think it is the lack of continuum in a stable habitat that has led to the appearance of new species and the extinction of others. The second part of this requires that a successful variant needs to be able to breed over a number of generations for that change to be fixed. Mm-hmm. And you probably, for humans, need 50 to 100 generations as a minimum, maybe longer, and we can't isolate human population for that long, and difficult to conceive of anything that could happen that would do that. So I think physical evolution is not something we should be worried about or expect other than medical interventions, but I don't think you can project those that far forward. And people say, well, what examples do you have of evolution not occurring? Well, the coelacanth, which lives in the Indian Ocean in the deep bottom of the sea, 600 meters or more down in the Indian Ocean and probably other tropical oceans, the coelacanth hasn't changed, what, for 100 million, 150 million years? And it's because where he lives, or it lives, hasn't changed either. It's dark, high pressure. There's no change at all to the environment of the coelacanth. And without the change in the environment, the coelacanth, which we can now see, fortunately, by sending down probes and submarines, the coelacanth living happily amongst the dinosaurs, or the time of the dinosaurs, is still living happily amongst us. They didn't see him, and nor did we, but he's there.
Yeah. Just yesterday, Richard's daughter, Louise, and I had 2 sessions, wonderful sessions with educators and high school students from the city of New York who are really being taught to be thinkers, not just pushing buttons. And these kids asked that same question. And I posed an interesting model, and that was the model of space exploration. Should we be successful in sending into space a mission for 200,000 years and then having them return after 200,000 years? The conditions that Richard was speaking of on that spacecraft, mutations, recombination, genetic drift, and so on, might very well have them evolve into a new species of Homo. And when they returned after 400,000 years to the very planet that sent them into space, they would not be able to interbreed with the very species that sent them out.
That's fascinating.
But there wouldn't be very many of them, probably. We'd fix them pretty quickly.
Let me just ask a follow-up really quickly, Dr. Johanson. I mean, is it possible, given some of the external pressures, you said environmental pressures, but I'll say external, that we are placing on ourselves in terms of the cognitive decline, the lack of education, the obesity crisis? Could we start to de-evolve as human beings, become less efficient, our brains actually becoming less productive? Could that happen? We talk about extinction, but what about de-evolution?
Well, I don't think so. I think there are enough genes being exchanged between populations around the planet that something, unless there is an extreme isolation of people who only eat Fritos, for example, and don't interbreed with anybody else, that might happen. Okay.
Now you're scaring me.
But I don't think so. I think that genes are flowing in and out of populations globally. And it's one of the things that keeps us moving along more or less as the same species. I mean, we can board a plane tomorrow morning and to Australia and exchange genes. And the exchange of these genes is true. The exchange of these genes certainly keeps the species moving along.
There's a couple questions that are sort of repeating a little bit here, so I'll try and reword these a little bit. But for Dr. Leakey, it says you spoke a few years ago. They say, I guess I heard you speak before, about extinction of Homo sapiens. When and why do you think that will happen? Now that's what we're sort of talking about here. But these environmental pressures that you're alluding to, is there something that you think about, worry about, forecast as far as driving that?
I think the environmental pressures that we're looking at today, irrespective of what's causing them, and I think there's been a lot of debate in the media, the press, Western world about whether this is humanly caused, or whether we're exacerbating it, or whether we're responsible, or whether we should do anything about it. Let's keep that aside. The fact is that last time there was major environmental change of the magnitude that we're seeing, things happened to Homo sapiens. And if you like, it was the beginning of agriculture. If you want to go further back than that, it probably seems to be connected to the origins of syntactic speech, which we see today. Clearly, today, with 7 billion people on the planet and heading for 10, environmental change of the magnitude that the first indications are suggesting we're going to face over the next 50 to 100 years are going to be so massive that there will be fundamental change to the way the planet operates in terms of the human population. We simply cannot sustain 100 billion, 10 billion people on the consumption patterns that we're looking at against the changes in climate that we're seeing beginning and which we can look geologically as having happened in the past. It's just too much. It can't be done. So that, I think, is a very fundamental cause of concern for me, and it's particularly important in developing countries like you see in Africa. And 85–90% of the world population is living at poverty or below poverty, and the impact on that population of massive climate change that we're seeing is going to be very significant. But to put another side on that, if ice melt in Greenland and ice melt in the Arctic and ice melt in the Antarctic is as described, and I've been to the Antarctic to have a look at it, and you can measure the amount of ice and you can see it beginning to melt quite dramatically, sea level rise is going to happen, and a rise of 5 meters of the ocean in the next 30 to 50 years is going to put most of the eastern seaboard under the United States in some difficulty, not to mention what happens on the western seaboard and what happens to the whole of Europe, and many countries will disappear in the Pacific and beyond. So, yes, I think in the next 100 years we're going to see fundamental changes to the way the world looks in terms of our existence on it.
Did you want to comment on that? I mean,
Well, I would just comment and say that I think that the human mind, the human brain, is infinitely inventive. And I think that it's moments of challenge that really push us to our limits and have us make major breakthroughs in technologies, major breakthroughs in agriculture, major breakthroughs in all aspects of living. We are really culture-bound animals. We are the most plastic, we are the most adaptable creature on the planet. And the changes that will come about through technological and cultural changes. I'm not quite as pessimistic, I think, as Richard is. I think that the species is aware that there are signals that species are dying out, that they're going extinct, they're disappearing, we are overusing land, and so on. And I think that people are beginning to put on their thinking caps and figuring out how to use new sources of energy, how to make energy go further, how to make crops go further, and to be much more vigilant about the sorts of things that have brought us to where we are now. We are, in many ways, introspective species, even though I call this Homo egocentricus, and we have a mind that is infinitely inventive. And I think that culturally, for instance, if glaciers came back, people in New York City just wouldn't grow hair. They just put on a coat or turn up the heat in the environment that they're living in. So I'm somewhat more optimistic about the future, I think.
This is a question more to do with I think, specific process. And let me ask you, Dr. Leakey, with the advent, the question is, of more sophisticated genomic sequencing, can evolutionary anthropologists use these techniques to fill in some of the gaps?
Say that again, sorry, I'm getting an echo.
I think they're talking about using genomic sequencing as a tool, as a route of exploration to try and fill in some of the gaps. Could evolutionary anthropologists use that as a tool?
Yes, I think absolutely.
I think they already are, to some extent,
right? Absolutely certain, for sure. But I think the fossil record is also very important, and I think the genetic evidence is what it is. The genomic work that's being done is fabulous. But I think we do need a fossil record because we need to look not just at the human story, but we look at the story of life and what has happened to life in the broader picture, the bigger theater of the changes that have happened on this planet over the last 3.5 billion years. I think that's what's important in putting us in perspective. I think putting our own origins in a clearer focus, the work on genes is going to be enormously important at pushing some of the frontiers that seem to be out of reach at the moment to the fossil record, the archaeological record. I think what we're learning from that is hugely important. But I think the bigger picture will be told by a combination of different techniques of investigation, and I think we want to be careful to try to remember that if we're talking about something that is true, all the lines should be congruent when we get to the end of the investigation.
Working all in the same direction, yes, please.
I think we're using genetics very effectively to understand human migrations, as Richard talked about. But we also are limited by the fact that biological material does not last very long. You need to have DNA, obviously, to do this genetic profiling. And we have Neanderthals at 100,000 years where we're beginning to see good DNA. And through that DNA, we're beginning to see that Neanderthals were different from us, but there was also a period of time, perhaps 100,000 years ago, the geneticists are suggesting, when we were capable of interbreeding with Neanderthals. But beyond that, we really don't have any good genetic material in the fossil record. We can use genetic similarities and differences to help classify animals and plants. We can use them to help reconstruct sort of the family tree or phylogeny of when certain branches came off. But certainly we will not be able to say what the genetics of, say, Lucy was, for example. Now, the last year when it was announced that within the next couple of years, the scientists in Leipzig will have a complete genome sequence of a Neanderthal. One of the questions that was debated was whether or not we should now take that complete sequence of Neanderthals, because after all, Homo sapiens was maybe not directly, but indirectly responsible for the extinction of Neanderthals. Should we now backbreed to Neanderthals and bring them back after destroying them? But the moral question is, what would you do with a Neanderthal? Put them in the state legislature.
You had that? Did you have that planned? You
No,
just
I
teed
didn't.
that up for yourself, didn't you?
I think international travel through airports of the world suggests that they're not all gone anyway.
When you look at all the various routes of exploration, Dr. Johanson, and you're still traveling. You've just been in Ethiopia and in South Africa. When you're using all these various routes of exploration, are there only specific areas in these countries where you can do your work? I mean, how is that determined where your team can actually excavate and look for fossils?
Sure, that's a very good question. It was like the old days in California when we saw the gold rush. In this sense, we sort of have the hominid rush. Everybody wants to go find their early human ancestor. And the governments, particularly Ethiopia, where I've worked since 1970, allocate places, geographic regions that are in our permit area. So this is a permit that is issued to us as individuals, where we can consistently work without any difficulty whatsoever. And scientists who work nearby do not impinge on other scientists' areas. We respect these sorts of boundaries. And so we do have well-defined areas where we work.
If there are budding anthropologists, Dr. Leakey, listening, I mean, how does one go about, starting that, getting a permit, just beginning in this field?
Well, I think it's slightly different in Kenya. The paleontological prehistoric research requires some form of permits, but I think generally speaking, they're not bounded by the boundaries that exist in Ethiopia. They're more site-specific or time-specific or much broader areas. And I think if scientists continue to collaborate, cooperate, and talk to each other, it becomes less important that you put boundaries around them. And I think restrictions of the kind that I think we've seen in Ethiopia may ultimately be counterproductive in that scientists are not talking to each other. And you yourself have alluded to the fact with me that at times you've been up to Addis and you wanted to look at material that has been published and you've been denied access to look at that material in its original form. Yeah. Now, I think that is very counterproductive and inappropriate. And I think we need to be very conscious of the fact that if we use public money to find things, and once we've published them and we got our first data out, there needs to be a more mature approach to sharing data. And I think, unfortunately, it's part of the world that we live in where you want to keep things very close to yourself. You want to have longer than is reasonable access because it helps you raise money for the next grant. You want to have your own opportunity to make a headline. And I think the funding mechanism that goes into scientific advance in prehistory, at any rate, in anthropology, has probably got a lot to answer for in terms of pushing scientists to demand, to try to find headline material, to try to monopolize the work that they've done in a way that I think is counterintuitive to looking for the truth. And I think there are big areas where dialogue and consultation are necessary today.
Let me just follow up quickly. We just got a couple more minutes left. But when all the things that you were talking about in terms of where the questions that you still want to answer on your explorations, taking into account all these routes of exploration, are you optimistic we're going to find those answers, given the state of science now, given the interest in this particular field?
Well, I think that if we look long and hard enough and widely enough, we will find the right geological deposits between 2 and 3 million years when our genus arose. We have, and Richard has in mind some places in Kenya. There are other colleagues in Ethiopia we work with that have ideas of where to look for that. I think we'll solve that problem. I think that whether or not Neanderthals could sort of sit around and speak to one another like we are today, that's a more difficult problem. But if we look at the circumstantial evidence that Neanderthals did not create art like we have, they probably did not have symbolic syntactic language like we do. There will be lots of questions. Will we get back to a point where we get so close to that common ancestor, to the African apes and ourselves, that we will not be able to make a decision by looking at a list of characteristics as to whether it belongs on our tree or an ape tree? There are a lot of mysteries, and the one thing that you said that caught my ear was that, yes, I would encourage young people to get involved in this field, not just to go out and stake your claim as to where you might find fossils, but to get involved with on the analytical side, because new techniques are coming along all the time that are allowing us to extract even more and more information from these fossils. A colleague in England, for example, has been using scanning techniques to look at the inner ear, at the semicircular canals, and say something about the locomotor abilities. We never thought that we'd use something like that. So I would encourage people, young students and our students at ASU, to not just go out and try to find their fossil, but to get involved on the analytical side. This is not just a discovery-driven field. This is a field that needs good minds, people who can really analyze and understand these features and add a new significant fact or bit of understanding to where we came from.
Let me just add one point to that, because I'm going to take it to a more contemporary issue, and I think we are well within the grasp of being able to demonstrate that bigotry and prejudice has no scientific basis, and it is purely bigotry and prejudice that are driving some of the divides that separate people of the world today. And I think if we can make it understood and clear that irrespective of our superficial features, we are one people, and we owe it to each other to respect each other as one species, one people with one origin, we may get over some of the hurdles that the 21st century are offering us. And I think this sort of research may go towards that.
You know, I was going to ask another question, but I think that might be a perfect point on which to leave it. How about a nice round of applause for Dr. Johanson and Leakey?
Thank you very much.
Thank you, Richard.
Thank you, Dan.